Hi everyone, today we're going to start 6.5, which is use proportionality theorems. The triangle proportionality theorem states that if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So if I look at my example here, if I know that TU is parallel to QS, and looking at my diagram, I see that with those red arrows, that means that RT divided by TQ is the same ratio as RU divided by US. The converse of the triangle proportionality theorem states if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So if we do know that RT divided by TQ is the same ratio as RU divided by SU, we then know that TU is parallel to QS, and so I can add arrows there. Here are some examples. Use the given information to determine whether segment BD is parallel to segment AE. All right, so using our theorem, I can write my ratios. So let's start with this side of the triangle. If I divide 6 over 3. Let's see if that's the same ratio as dividing those two sides of the triangle, 8 over 4. And if we do that math, we end up getting that 2 is equal to 2. Therefore, those ratios are the same. So I can then add those arrows saying that BD is parallel to side AE. Let's look at our next example. So I want to use my theorem, set up my ratios. If I do 2 divided by 1, we want to see if that is equal to 3 over 1.2. If you do the math there, you will see that 2 divided by 1 is just 2, and 3 divided by 1.2 is not 2. So these are not equal, meaning that BD is not parallel to AE. Find the length of a segment. So in the diagram, we know that QS is parallel to segment UT. And if you look at the diagram, we see those red arrows. RS is equal to 4, ST is equal to 6, and QU is equal to 9. We want to know what is the length of RQ. I'll put an X there. So I just want to solve for X. To do so, we got to use our theorem. Let's set up our ratios. So I have 4 over 6 is equal to, we'll look on this side, X over 9. If I have ratios and I'm trying to solve for X, the easiest way is to cross multiply. So 6 times X is 6X. 4 times 9 is 36. My last step is to divide by 6 on each side. So X then is equal to 6. Shoe rack. On the shoe rack shown, AB is equal to 33 centimeters, BC is equal to 27 centimeters, CD is equal to 44 centimeters, and DE is equal to 25 centimeters. Explain why the gray shelf is not parallel to the floor. So I actually have all the sides on my triangle. So if I plug in what I know, so AB is 33, BC is 27, CD is 44, and DE is 25. So let's set up our ratios. So I have 27 over 33. Let's see if that is equal to 44 over 25. And if I do 27 divided by 33, I end up getting a decimal of 0.8181, and that decimal repeats itself. That is equal to 44 divided by 25 gives me 1.76, and we see that those are not the same. So the gray shelf is not parallel to the floor. All right, we want to figure out what is the length of YZ, so I'm going to put an X there. I am just going to look at my proportions. So if I do 44 divided by 35, We're going to set that equal to the other side of my triangle, which is 36 over x. Cross multiply, so 44 times x gives me 44x. That is equal to 35 times 36 gives me 1,260. Divide by 44, divide by 44. And we actually don't get a pretty number here, so I'm going to keep it as a fraction, and I know it's going to be a weird one. So 315 divided by 11. If you do plug this in your calculator, it gives you approximately 28.63, and that 63 repeats itself. So that's why we can't, just use our decimal. We have to use a fraction because it isn't an exact answer. All right, let's practice this again. So determine a value of the variable so that our segment DE is parallel to the segment BC. Now, if we look at our examples here, instead of just an x, we actually have an equation. But we want to treat these problems very similar to what we did before. So let's look at number 11 here. So let's start by looking at this side of the triangle. So 12 over 6 is equal to, now we'll look at this side of the triangle, x minus 4 over 8. Once again, we are going to cross multiply. So I'm going to have 12 times 8, which is 96. And that is equal to, now we're multiplying 6 by that entire equation. So I'm going to write it as 6 times x minus 4, just so I don't forget to distribute the 6 inside the parenthesis. So when I do that, I'm going to get 96 is equal to 6x minus 24. Now I can solve for x by adding 24 to each side, and I get 120 is equal to 6x, meaning that 20 is equal to x. Now I'm going to double check my answer. So if I look at my original ratio, I had 12 over 6 is equal to, now instead of x, I can plug in 20 because I know what x is equal to. So if I have 20 and I subtract 4, I then get 16 over 8. And if you look at these ratios, we see they are the same. This becomes 2 is equal to 2. And I know I'm correct. So this is an easy way to double check that your x value is correct and you should be doing. Now let's look at our next example. I want to do the same thing, set up my ratio. So I'm going to have 18 divided by x minus 4. That is going to be equal to these two sides, 15 divided by x minus 5. I want to cross multiply. And remember, I'm going to rewrite this as x times the quantity, 15 times the quantity x minus 4 is equal to 18 times the quantity x minus 5. And I'm only doing this so I don't forget to distribute. So let's scroll down a little bit. So I need to distribute this 15 inside my parentheses, which gives me 15x minus 60 is equal to, same thing over here, distribute that 18 inside, and I get 18x minus 90. Let's scroll down a little bit. All right, so if I subtract 15x from each side, I end up with negative 60 is equal to 3x minus 90. I need to add 90 to each side. That will give me 30 is equal to 3x. Divide each side by 3, and so 10 is equal to x. Since I have my x value, I now want to plug x back into my x values for my ratio just to double check that it is correct. So I had 18 divided by x minus 4. Well, x is 10, so 10 minus 4 is 6. This is equal to, now I have to plug in x for my ratio over here. I have 15 divided by x minus 5. Well, once again, 10 is x, so 10 minus 5 is 5. If we simplify both these fractions, we end up getting that 3 is equal to 3, which is the same it should be. So our answer is correct. Our next theorem, if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So here we want to find the length of AB. So I'm going to call AB here x. And so I'm going to set this up just like I did with my other problems. So I'm going to look at the triangle here, set up my ratio, and that would be 16 over x. That is equal to, I'll look at my triangle here, and I have 15 over 18. I'm then going to cross multiply. So x times 15 is 15x. 16 times 18 is 288. Divide by 15 on each side. I end up getting that x is equal to 19.2. I can't have a decimal here because it is a pretty number. I don't have a repeating decimal. So in this case, that answer would be fine. If a ray bisects an angle of a triangle, then it divides the opposite sides into segments whose lengths are proportional to the lengths of the other two sides. So I'm going to scroll down. So you can see here that I have a ray, which is red, bisects this angle C, meaning that AD divided by DB is equal to CA divided by CB. Those two ratios would be congruent. So let's kind of put all that together. So for my first example, I see that I have an angle bisector. So when I set up my proportion, it's going to be this proportion, which is 4 divided by 4, is equal to, then we have this proportion here, 8 over x. So right away, we kind of see what x should be. It should be 8, right? Because our ratio on this side is 1, which means our ratio over here should also be 1. But let's just cross multiply. That way we can practice. So 4x is equal to 4 times 8, which is 32, meaning that x is equal to 8. And we are done. Now looking at this last example here, I want to do the same thing, so I'm going to look at this and this triangle here. So 2 over 3 is equal to x over 3.5. Cross multiply. 3 times x is 3x. 2 times 3.5 is equal to 7. Now we do get a ratio here of 7 over 3. And so I would just keep it like this, and we have found our x value.